My name is Brad Johnston, and I'm glad you've joined us for today's seminar. It's called Drillhole Exploration Workflows in Target and Target for ArcGIS. Before we begin, just a few housekeeping details. Today's seminar, Natalie will be presenting, and then we'll be taking questions at the end of our session. All right. Today, we will be looking at working with drill hole data from planning to 3D visualization and the generation of geological models. Natalie will show us how drill hole data can be integrated with other exploration data and how various geological interpretation workflows are applied to different stage exploration projects.
Thank you, Brad, and welcome everyone. As Brad mentioned, we're going to look at two projects today, and we're going to use both Target and Target for ArcGIS. First Target in BC, and then Target for ArcGIS in Oregon. We're going to do some geological mapping, geophysical data integration, geochemical analysis, drill hole plotting, and geological modeling. Our first stop is a MOLLE project in southeast British Columbia. In the early stages of this project, historical data were reviewed, and an airborne geophysical survey outlined a large intrusive feature associated with a previously defined soil anomaly. In 2009, an IP survey was completed, and drill targeting continued to test beneath known mineralization related to intrusive rocks. Early in the exploration cycle, there were many opportunities for collaboration between the geologists and with the geophysicists. Here we have some mapping and interpretation of faults and alteration zones imported from a MapInfo tab file. And here we have a table of structural observations. These can be plotted on the map using the strike dip symbols option. Adding these strike and dip measurements draws my attention to this area here. Does this structure continue, consistent with the observations? Overlaying some IP lines shows that line 5.5 goes right over this area. At this point, I could discuss these assumptions with the team, integrate the IP section and see if it shows any evidence of a fault, or edit the file. Then export this selection to a new MapInfo tab file that I can send back to my colleagues for comparison. Using Target, it's easy to work with the rest of the project team and GIS application data. Let's skip ahead to that MAG survey and the first round of drilling. Here's a satellite image of the project region. It's a rugged area. Our project is highlighted in the southwest. We have regional geophysics, magnetics, and radiometrics as gridded data. The grid display options have been updated in version 8.2. Among some of the new options, we can have shading and add a color bar, all available in one dialog. Here we'll add the magnetics to our current map. Locating the color bar, and now we may wish to also add the topo as contours. Here the 500-meter contours are darker and have been labeled. When we close the map, we'll be prompted to save when changes have been made. You can also save the map via the menu or using the Control-S hotkey. Zooming into that project area highlighted on the regional map, we'll now look at some background soil sampling. Results filling in around a previously sampled target area and along some ridgelines. We've categorized the copper results in the histogram tool. The color breaks are mirrored in the database and color-coded as symbols on the map. The histogram can also serve as a legend. If desired, the surface samples can also be gridded. Here, copper was gridded in log transform using a Kriging interpolation algorithm. We are also interested in relationships between dependent or correlated attributes. In the probability tool, we can see that there is a log normal distribution of copper. Selecting the top values, we can isolate the most anomalous copper results. These can be correlated with other elements of interest. In the scatter plot tool, a plot of nickel versus zinc shows the selected anomalous copper values are highlighted. These samples are linked in the database and the map. We can plot these locations straight from the scatter tool. These analysis tools are part of the geochemistry extension. Now we'll look at the drill holes. Here are the colors around a known soil anomaly. The drilling results are included in collar, survey, and downhole data, and these are imported into a target project. There are several common import options, and when new drilling results are available, just refresh the project to import the up-to-date data. Double-clicking on these documents, here in the Project Explorer, will open them as they may be closed, or in this case, simply minimized at the bottom of the workspace. Now we can use Target's drill hole plotting options to plot results, as in this strip log. Strip logs can be used to create visual reports of one, some, or all of the holes in the project. This strip log also identifies some significant intercepts. Intercepts may be calculated using the composite database tool. Here, a first-order cutoff was set to 0.01% moly over 3 meters. But they can also be selected freehand in the strip log and added to a report using the compositing tool. Here's a plan view of the drill holes with the traces projected to the surface. After we've refreshed the project or calculated new fields, such as the significant intercepts with the new results, maps are easy to update too. We can update this plan map to include the new intersections. The plan map tool has numerous options which we can modify or leave as is. I'm going to add a new tag name so that I don't overwrite the 2013 map. Creating sections is very similar to creating level plans, with options for plotting a number of consecutive sections and various types of data plotted along the traces. Here are 3 sections that I created earlier. These are dynamically linked to each other in section and in plan, and also to other plan views of the same area. One of the project geologists added some data with detailed annotations to one of the sections in the main area where an intrusion is thought to be present. I use these annotations as a starting point for wireframing tools to digitize interpretations in each section in order to create a simple geological model. Here are the interpretations in each of the sections that I drew earlier, and now we'll add a new interpretation to this section. While we are digitizing, we can snap to the true 3D locations and other layers in the map. Next, we will use the wireframing tools to connect these interpretations into a surface in 3D. Here are the digitized interpretations from each section. And here is the one that we just added. These interpretations can be joined together using the wireframing tools. In wireframing, we can add bifurcations, and also ends. The result is a new surface that illustrates my interpretation of the intrusion, which I can share with others. If one of the other geologists has created interpretations for other sections in the project, then these can be added and we can continue wireframing. Similar geological modeling workflows have been used on our second, later stage exploration project in South Central Oregon. The Quartz Mountain project was acquired by Alamos Gold in 2013. Historic and recent drilling combined to approximately 80,000 meters of drilling. The geologists on this project use Target for ArcGIS as their platform for planning and all base work for resource and reserve estimates. Target for ArcGIS has the same tools as Target, but in the Esri platform. The geologists spent the first few months modeling historic data from several hundred drill holes. They created many sections. Each north-south line in this view represents a section with 50 feet between each. I've used draft mode here in layout view so that the contents of each section don't need to render. You can create all section data frames in a single MXD when you're using Target's wireframing tools. Tag names, like the date used here for August 20th and 22nd, can help to keep you organized. Each section has its own data frame where the geology has been digitized. Here's one of the sections. In all, 15 sections were digitized with all of the same data parameters and slicing information. This creates a number of layers that can be toggled on and off. Or queried using ArcGIS tools. In this section, we can also see several units that were digitized using the wireframing tools, the same ones that we saw in the Target project that we looked at earlier. In 3D, all the section interpretations are loaded and can then be joined together using the wireframing tools. This geologic model will be used to help define the bounds of the resource and reserve update. It can be exported to a 3D multi-patch shapefile, a DXF for the resource team, or a 3D PDF to easily share with management. Using Target for ArcGIS has saved the Alamos team time and money and enabled collaboration between the geologists and the resource team, as the geologists have been able to be active participants in the modeling. The teams have strong technical links. As the geologists are drilling, they are updating and passing their models to the resource modelers and getting timely feedback. I'd like to acknowledge Alamos Gold and Eagle Plains Resources for sharing their projects so that we could illustrate how Target can help you integrate exploration data and collaborate with your colleagues at various stages throughout your project. We have a few questions that have already been submitted. And we'll answer as many as we can right now.
It's Brad here. Thanks, Natalie. I'm going to encourage everyone to enter their questions. A few have started to come in, and while we're doing that, I do want to just remind everybody that the capabilities and workflows that Natalie was showing us today, they are available in the most current releases of Target and Target for ArcGIS.
Okay. So the first question was about the structure and dip. The structure symbols, the strike and dip symbols. That option in Target is in the map menu under symbols, and all you need is an X and Y field for the location of the symbol and a strike and dip fields with the angles for those symbols. I believe it was imported from a map info tab file originally. Someone's asked if you can wireframe underground workings. The wireframing tools can work on a whole bunch of things, actually. So as long as you digitize polylines or polygons in your section or level plan views, then you can wireframe those things together. There's actually a wireframing video that shows this process in greater detail that is available on our website. We can provide a link to that for you if that would help show a little bit more detail. Can you create the content of a section in the layout? So I showed our ArcMap layout view in draft mode only because there's many sections in that layout, and it takes a little while for my laptop to draw them. You can toggle between layout and data view for your sections, and depending on how you plot your sections, you can use the MXDs in different ways. When I'm wireframing, I like to plot all of my sections to single data frames, single individual data frames, and then arrange them on the layout. When I'm doing other things that don't involve wireframing, I'll often plot sections with plan views and legends to separate data frames and then use one MXD per section map. When you're in layout view, you can't digitize. You have to be in the data frame view in order to digitize your interpretations. Someone's looking for online courses. I think probably one of the best starting place might be some of the how-to videos that are available on our support site. We can find out about online courses and see what's coming up in the near future. We have some more videos that will be posted with our 8.2 release, and those will be available soon as well. But the wireframing video that's already available is a great resource to go back to look at this process in more detail. Someone asked about updating the section in Target for ArcGIS. In Target for ArcGIS, you don't have the same recreate option that you have in Target, but you can save your parameters for different maps that you're making and then replot them later on. And this is actually what the Alamos project had going on. They were saving their parameters from some of the different sections, and they were using the date as a tag name on their data frames and shapefiles so that they could recreate them and have them sort of like versioned from August 20th to August 22nd to August 26th. And so each of the sections, depending on what day they created it, use these parameters that are available in the Load and Save tab. Someone asked if this only applies to mineral deposits. It doesn't. If you have other types of subsurface data, you can, and maybe with wells, so for instance, water wells or geotechnical data or maybe some monitoring type of things, then these tools can be used for those environments as well. In Target, subsurface data is always assumed to be Z negative down. So in your Drillhole project, there's actually a parameter that you can use to flip it over. I think it's called Preferences. I can check. If you're using Target for ArcGIS and you look in the Target Project menu under Preferences, there's some options for dealing with up and down in there, but we usually assume that Z is negative down. Somebody asked about using a Mac. I believe that there are people that run these sorts of programs on a Mac using a Windows emulator. It's not something that's supported, but it's possible. Target does have an import option from Access. I mentioned the import options early on, and that there's some standard ones. You can import data from text files, such as CSV files or text files, Excel or other databases, which includes Access, SQL, really anything that you can create an ODBC connection to, and also it connects directly to Acquire, and you can import LAS files for seismic results. Someone asked about the computational requirements. These are available on our website under System Requirements. Usually you need maybe a few hundred megs of hard drive space to install the program. You need room for all your data, and we recommend 4 gigs of RAM. A good graphics card driver, which is usually standard in most modern computers, usually isn't something that you have to check through the parameters on, but those come standard in most computers now. But if you go to our website and look under System Requirements, then you'll find that information there, and we can send you a link as well. Someone asked about section locations. In Target and in Target for ArcGIS, one of the options for defining a section is to actually just draw it right on a plan map, but that often isn't very accurate. So you can type the numbers in for the section location, the center, and dimensions of that section as well. Somebody asked about a claim in a remote location. There's actually a lot of free geoscience data, especially for that particular area, from provincial and federal geological surveys. You'd certainly be able to find magnetic data that covers, and actually some of the magnetic data that you saw in my presentation for the first project was regional government geophysical data. The magnetic survey that the Eagle Plains did later on was not part of this presentation, so there's lots of free data available online. I think I've answered many of the questions. Oh, someone asked about plotting to a PDF. So if you're in, usually the PDF options are under the print capabilities. And there's also an export map option in ArcGIS that you can export your layout directly to a PDF. I often use this by turning on and off the layers that I do or don't want to see, and then exporting my layout to a PDF. If there's something else that you're interested in doing, or if this doesn't meet what you're after, just drop us a line and we'll look into that more carefully. Oh, and the 3D view can be printed to a 3D PDF. That's one of the export options in the 3D viewer in both Target and Target for ArcGIS. I don't think there's an automated option to plot each data frame to a PDF in a batch mode. That might be something that could be created with a little bit of Python though. All right, I might have missed some of those, but hopefully I answered most of them. Back to you, Brad.
All right, thank you, Natalie, and thank you everybody for participating, giving us great questions. I just wanted to remind you the recording for today will be made available in a couple of days, and we'll send you a link via email. Now, today's stories featured Eagle Plains and Alamos Gold, great stories. And if you are exploring and you have projects that you are advancing and you're using technology and Geosoft technology especially, that would be wonderful. We would love to hear your stories. And if you had any other questions about today as well, please send them to our email mailbox, explore, E-X-P-L-O-R-E, @geosoft.com. Okay, thanks so much, everybody. Take care.